All right, so today we'll be looking at 9.5, and that's properties of logarithms. All right, so there's four properties I'll give us, and then we'll go through examples using them properties on these problems. Um, in these properties of logarithms, they mimic the properties of the exponents. So the first one I got is the product rule of logs. And the product rule tells me that if I got a product, so log base A of m times n, I would do just like I would do if I was multiplying variables. I would add those exponents. So I would rewrite a product as a sum of logarithms. So it'll be a log A of m plus the log A of n. And all these properties can go either way. So I can rewrite a product as a sum of logarithms, or I can rewrite a sum of logarithms as a product. So we learn these properties so when we solve the equations in the next class, we'll be able to do a few things with them. Next one they go over is the power rule of logarithms. So that deals when you got log base A of a base to an exponent. So the power rule of exponents is when you had something like x squared in parentheses to the third power, you would multiply them exponents. So when you got a log with a result that has an exponent, you rewrite that as a product of the exponents. So if you're taking a log and you got a result with an exponent, you're basically just going to bring that exponent down to the front and write it as a product. All right, next we got the quotient rule of logarithms. So the quotient rule is for division. So I'm going to have a log base A of m divided by n. So just like when you had exponents on variables and you were dividing, you would take the top exponent minus the bottom exponent. Same thing on these. You'll take the log A of m, which is the top, minus the log A of n. So basically the top is always going to be positive and that bottom was always going to come out negative. All right, so one more property and then I'll show you these problems. So this is the log of a base to a power. So if I got log base A of A to the X, well, we were doing problems the other day with problems like this. Anytime the log base matches the base of a result to an exponent, the answer was always that exponent. So notice the difference between this and the power rule, though. On this log of a base to the power, the base of the log is matching the base of that result. Up here, you had a base A and the result was M. So since those didn't match, you brought the P down and rewrote that part as a product. All righty, so what we're going to do is start these examples. So let me say I got one more coming in. So I'm going to start these examples. In the first examples, want me to express as a sum of logarithms. Okay, so they want me to express it as a sum. So I'm going to start out with a product, and I'm going to be rewriting it as addition. So this one has log base 22 of 22 times 484. So they don't want me to evaluate this, they just want me to rewrite it as a sum. So here's my product. My factors are 22 and 484. So what I would do is distribute my log base 22 to the 22, and then I would add that to a log base 22 of 484. So I've written it as a sum, and I'm done. So what I did on these, I did one with logs, and then I did examples using natural logs. So this is the ln of b times c. So I got two factors, b and c, so I'm going to rewrite this as the ln of b plus ln of c. All right, so I'm written as a sum, so we're happy and we move on. So questions on that part yet? All right. So the next two want me to express as a product. So to express it as a product, they're going back to my second property, which was the power rule of logarithms, which said if I had a log base a of m to the exponent p, I rewrite that as the exponent p times the log a of m. So that's what they mean by writing them as a product. So for number 3, they're giving us log base 10 of x to the 15th. So basically, since my log base does not match the base of that result, I'm going to rewrite it as a product by moving my 15 to the front, because that's the exponent, and then taking that 15 times the log 10 of x. Okay? And y'all, that's all you're doing to that. It's now written as a product. All right, number 4, ln fourth root of 6. So the other day when y'all was doing 9.4, I showed you how to rewrite these without the radicals. So the first thing I'm going to do is rewrite that without the radical and write it as a fractional exponent. So the 6 don't have an exponent, so that would be a 1. And then the index of the radical is a 4. So that becomes a fourth root. So now I've got my ln and my base to an exponent. So now I'm just going to bring the exponent out front so that I get 1/4 times ln of 6. Hey, y'all, so remember, that's the trick on these is anytime they start you with a radical, you want to convert it out of the radical into a fractional exponent. All right, so we've written them as a sum, written them as a product. The next couple want me to express as a difference of logarithms. So let me go back. The one that you would express as a difference would be the quotient rule. Log base A of m divided by n equals log base A, the top, minus log base A of n, the denominator. Okay? So that's what I'll be doing on the next two. So 5 has a log base t of d divided by 3. All right, so I got division, so I'm going to rewrite it as a difference. So it's log base t of d minus the bottom, which will be a log base t of 3. All right, then we'll do the same thing with the ln. ln of m divided by t. All right, y'all, so let me see. When I rewrite this, it'll be what, an ln of m minus the bottom, which is an ln of t. Now, I'm just writing ln with a big L on some of these so that y'all realize when you do this in MATLAB, that's not a capital I, that's a little L. So I'm just trying to get y'all to realize that. That's why sometimes I'll do a capital L on those. All right, so if there's no questions over those first 6, what we're going to do now on these examples is we're going to rewrite as sums or differences. So I'm going to rewrite as sums or differences. Now, one thing you also got to remember, if I got anything that looks like this, log base A of m to the p, I got to bring those exponents down also and bring them to the front to be totally simplified, okay? I'm just saying that because some of these will have exponents on them. So y'all, number 7, I'm going to start out with an ln x to the 4th, y to the 6th, and a z. So I do know that these are all being multiplied, so they will be rewritten as a sum of logarithms. So I'm going to distribute my ln to all 3 factors. So I'll have an ln x to the 4th plus an ln of y to the 6th plus an ln of z. So you had 3 factors, you got to have 3 terms, okay? Now, I just showed you that power rule because I got exponents on these 2 ln's. So these 2 exponents have to be moved to the front and rewritten as a product so that this one will become 4 times the ln of x plus the second one, move that 6 down, that becomes a 6 times the ln of y. And then the last one, I had an exponent of 1, but that ain't changing nothing. So that's just going to stay at ln of z. So now my exponents are all brought down, and I've got all my natural logs written as a sum. So, question on that? Oh, looks like I lost one of y'all. So
Yes,
you
it's
still
me
here.
again.
All righty, so same thing. So I'll have quite a few of these doing that. They'll just change it up the way they look. So this one has a log base b, p to the fourth, q to the fifth, all divided by m to the third, b to the ninth. So on this problem, since we got division, the two factors that are on top, when I rewrite this, will be positive. The two factors on bottom, when I rewrite this, will both be negative. So we got log base b of p to the fourth plus the log base b of q to the fifth. So those two factors are on top, they're going to stay positive. Now the next two factors are on bottom, so they're going to be negative. So it'll be a log b of m to the third minus my log b of b to the ninth. All right, so three of these, I'm going to tell you, I'm going to move the exponents to the front on these first three. But notice what I got here. I got log b of b to the ninth. That goes with my fourth property I showed you a while ago. And that fourth property here said that if I got a log base a of a to an exponent, the answer was always the exponent. Well, if you notice, so that's going to equal that 9 there, okay? So good job.
Okay.
So we'll rewrite these three, bringing them exponents down, and then that's just going to become a 9. So let's see what we get. We get 4 log b of p. And what makes these problems sort of crazy is you don't really get rid of stuff, you're just rearranging it.
Mm-hmm.
All right, so let's see, what's that? A 5 log b of q minus this one would be a 3 log b of m. And then at the end, we said that was just a 9. All right, so we're happy the exponents are down and nothing else can be done to that. All right, let me let that dog out real quick.
Okay.
Ooh, little dogs. They get back home and they go crazy. All right, now I'm going to do this with ln. So I got an ln of 2 divided by 9x to the 9th y. So basically the same problem as that, but we're using ln's. And then I notice I got 3 factors in the bottom and only 1 factor on the top. So all 3 of these factors will be subtracted on the bottom. So we'll start distributing our ln. So we get an ln of 2. That one's positive because it was on top. Minus my ln of 9. Minus my ln of x to the 9th. Minus my ln of y. So let's see, all 3 of these were on bottom, they're all negative. So technically I got one more move. Do you see what that move is?
I don't see it.
So think about your power rule. So remember, my power rule dealt with the ones with exponents, right?
Mm-hmm.
If it had
you would multiply the exponent by the.
So you see this ln of x to the 9th, since that exponent 9 is there, that one has to be brought down in front of its ln so that
Mm-hmm.
you get your ln of 2 minus your ln of 9 minus, this now becomes 9 times the ln of x, and then minus my ln of y at the end. So just remember, MATLAB would take that answer, but it would not give you credit because it would tell you you're not in the correct form.
Mm-hmm.
So in the form, all those exponents have to be brought down. All right, so I'm going to plan for radical again. I'm going to do a log square root of c to the 6 times a d. So first thing we want to do is get this out of this radical form and write it with an exponent. So I'm going to bring down the log. Since I got more than one thing under that radical, I'm going to put it in parentheses. So I'm going to put my c to the 6d in parentheses and then figure out my exponent. So the top number is going to be a 1. The bottom number is the index and the radical. So remember, if there's not a number shown for the index, it automatically is a 2 for the square root. So I'd write that as a 1/2. Now, the next thing we want to do is take both of these exponents on the c and the d and multiply by the 1/2. So the d don't have an exponent, so we need to write a 1 for it. So let's see what we get. We would multiply 6 times 1/2, so 6 times 1/2. You just multiply straight across and get 6 over 2, which would turn into a 3. So 6 times 1/2 gives the c an exponent of 3. The d has 1 times 1/2, which will stay 1/2. So all we did so far was got it out of the radical and into fractional exponents. Now, since this is a product, when we rewrite it, they will both be positive, like a sum. So you'll get a log c to the 3rd plus log d to the 1/2. All right, so my log, those were a product. They're rewritten as a sum. And I got one more move. And that's these two exponents you see here. This 3 is going to get moved into the front of its log. That 1/2 will get moved in front of its log so that I get a 3 times the log of c plus, oh, what did we get there? 1/2 times the log of d. So no more exponents are up there. And we're done. So you just sort of got to follow through and get them out of those radicals for sure. And then figure out if you're writing them as addition or, like we had up here, subtraction. And really the only time they're going to be subtracted is if you got a fraction. Okay?
Okay.
All right, so now they're getting bigger. A log base c. This one has big parentheses and a big radical. And this radical has a 4th root. So on top is a M8 N20. On bottom is a C7 A5. So just like on that problem I did a while ago, the first thing I want to do is get it out of this radical. So we're going to bring down the log base C, and I'm going to put this big fraction in parentheses, M8 N20 over C7A5 to an exponent. So I'm going to replace the radical with a fractional exponent. So that'll be a 1 on top. And the bottom number of that exponent will be the index of that radical, which is a 4. All right, so next, you would distribute the 4 times every exponent in there. So you got an M, that is an 8 times a 1/4. So treat that like 8 over 1. So you get 8 over 4, which gives me a 2. So that gives me M to the second. N, I got 20 times 1/4. That'll be 20 over 4, which will be, what, a 5. So N has an exponent of 5. Down here we got 7 times 1/4. So that's going to be a 7 over 4. I cannot reduce that. So that's going to stay C 7 over 4. And then the A has a 5 times 1/4. So that'll be, what, a 5 over 4. So it looks like the top exponent simplified nice, and the bottom ones left me with fractions. All right, so now I'm going to rewrite it as sums and differences. If they're on top, they're going to be positive. If they're on bottom, they're going to be negative. So you get a log C of M squared plus a log C of N to the 5th minus a log C of C to the 7/4. So now I'm starting to subtract that bottom, minus log C of A to the 5/4. All righty, so we've written them as sums and differences. On 3 of these, I'm going to bring exponents down to the front. Now, the reason I didn't do that to that one, because this is a log base C of C to an exponent, so that answer is just going to be the exponent, which is the 7/4. So the log base C of C to the 7/4 equals 7/4. So that went back to my 4th property I gave you. So the other 3, I'm going to bring exponents down. So this one will become 2 times the log base C of M, plus the second one is 5 times the log C of N, minus log C of C to the 7/4 became 7/4, minus the last one I'm going to bring down to 5/4 times the log base C of A. So this is probably one of your more difficult problems, but the first thing I did was get rid of that radical. Then I distributed the exponent. Then I rewrote it as sums and differences and simplified. So that was the last one doing that. So they always save the best for last on those, okay?
Mm-hmm.
So now we're going the other way. We're going to express as a single logarithm. So express as a single logarithm. So we're going the other way. So this is what, 12? I got log base C of 67 plus log base C of 59. So since they're being added, we will rewrite them as a product, which will be 67 times 59. All right, so they want us to multiply that out. So let me see. What is 67 times 59? So that'll give me a final answer of a log C of 3953. Alrighty, 13 is subtraction. Log of 100 minus log of 10. So when you got subtraction, the positive goes to the top, the negative goes to the bottom. So this will be log of 100 divided by 10, which that simplifies to a log. 100 divided by 10 is 10. So check it out. That's the answer for part of this. But this one also simplifies further. So they're going to have you simplify this one further because the log of 10 is going to equal 1. So just remember on 13, they'll have you write what you get, and then it will have you simplify that further. And just remember, anytime the base matches the result, that answer is always going to be 1 on those, okay? All righty, moving on. So 14, I got a 1/3 log x plus a 5 log y minus a 4 log x. So now let's explain this. And so if I'm going to rewrite sums and differences as a single log, the first thing I need to do is move them exponents back up. So see, that was the last thing I did, writing them as sums or differences. It's the first thing I do when I go the other way. So that this would become a log x to the 1/3 plus a log y to the 5th minus a log x to the 4th. All right, so my exponents are brought back up. Now, I'm going to write it as a single log. Now remember, if they're on top, if they're positive, they'll be on bottom when they're negative. So I'll bring out that log. On top will be an x to the 1/3, y to the 5th, all over. This one's negative, so that x to the 4th will go to the bottom. So on this problem, technically we're done, but this one will simplify further. So this simplifies further. And guess what? The part that simplifies is because of these x's. You cannot have x's over x's in your final answer because they will simplify. So to simplify them x's, you find the largest exponent, which is the 4, and it's on bottom. So that means the x's will stay on bottom where the biggest exponent was, and then you take the 4 and you subtract 1/3 from it. So exponents, you always take the larger exponent minus the smaller. So 4 minus 1/3 So I'm going to turn that back into a fraction. And it looks like my x is now going to have an exponent of 11 thirds. The y to the fifth stays on the top. So you'll probably have to simplify this just like I did. So find the bigger exponent, subtract the smaller. Had that x to the 4 been on top and the x to the third been on bottom, then that means my x would have been on top with the y because it would have had larger exponent up there.
I have a question. Would it take mixed fractions,
Um,
like the one with the whole fraction?
I would probably keep them as the improper fraction when you're doing them in MATLAB. I don't know if it would take it like, I think what you're saying is the x be like a 3 2/3.
Mm-hmm.
I don't know that it would take that because usually they just want them in, when they say write them in fraction form, they don't really want those mixed numbers, okay?
Okay.
All right, this one's doing similar to the same. This was an ln x to the 6 minus 3 ln third root of x to the 5th. All right, so the first thing we'll do is get it out of this radical. So bring down this ln x to the 6 minus 3 ln. So we're going to write this x without that radical. So it's going to be a fractional exponent. So the top exponent will be the 5. The bottom exponent will be the 3. So remember, these roots always go to the bottom, okay? All right, next, we need to bring this exponent up. So this ln x to the 6 minus. So if we bring this exponent up, this 3 will then multiply by the 5/3 that's already there. So to multiply them, the 3's cancel, so that just gives me a 5. So this will be ln x to the 5th. And hey, these calculators would have done that. 3 times 5/3 gives me 5, okay? All right, so the exponents are up. So now I write it as a single log. X to the 6 goes on top. Since this is being subtracted, the x to the 5th goes to the bottom. Now remember, just like up here, I had x's over x's. Well, right here, I got x's over x's. So I'm going to bring down my ln. 6 is a bigger exponent than 5. So I take the 6, subtract 5 from that. That leaves me an x to the first, or just a x. So if your answer is on top, you don't need to put the 1 on the bottom. But had this been like an x5 over x6, then my answer would have been a 1 over x. Okay?
Okay.
But since my exponent was bigger on top, I didn't have to put my 1 under there. All right, I got 2, but these 2 are going to test your factoring ability. So this one is an ln of x squared plus 10x plus 24 minus the ln x plus 6. All right, so nothing I can do but rewrite this as a single log. But so remember, this is being subtracted, so it'll be on the bottom. So I have my ln. On top will be x squared plus 10x plus 24 divided by x plus 6. So to simplify this, you're going to have to be able to factor that top. Okay, so that's how we simplify rational expressions like this. Now the bottom has the x plus 6, so nothing we can do to that at the moment. So let's factor this top. We got an x squared plus 10x plus 24. X squared means you got an x and an x. Last sign's positive, so both of these factors will have the same sign as that middle number. So they're both positive. So what we need now is the factors of 24 that equal 10. And
6 and 4.
exactly, 6 and 4. And we knew one of them had to be a 6 if we was going to be able to simplify this. Because my last step, anytime you got a factor on top that matches a factor on bottom, you're going to cancel them out, basically turning them into a 1, so that my final answer will be ln of the x plus 4. Now, since this one didn't end up as a fraction, you will need the parentheses around the x plus 4, because if you don't, the computer will think it's like an ln of x plus a 4 after that, okay?
Mm-hmm.
So you gotta put parentheses on that one. Righty, so one more, we'll see what you do to this. We got a log x squared minus 5x minus 14 minus a log x squared minus 4. So it looks like nothing we can do except write it as a single log. So the x squared minus 5x minus 14 goes to the top. X squared minus 4, since it's being subtracted, goes to the bottom. So I'm going to tell you what, since both of these have x squareds, both of these are going to need to factor. So you're going to have to factor the top and factor the bottom. So you got an x squared on top, so that's going to be an x and an x. Anytime the last number is negative, they'll have unlike signs for your factors. So now we want factors of 14. That'll give me a 5. So what's that? 1 and 14 don't work. 2 and 7. Yeah, 2 and 7 will give me a 5. So the larger factor has the same sign as the middle. So the 7's negative and the 2's positive. And if you add a 2 and a negative 7, you get that negative 5.
Mm-hmm.
The bottom, that's perfect squares. That'll be an x and an x. Last one's negative, so one's positive, one's negative. In factors of 4, that'll give you 0. So 4 and 1, that gives me a 3. But look at that, 2 and 2, those give me 0 when I subtract. So I get a plus 2 and a minus 2. Now I don't know, you got all my programs at the school, didn't you?
Mm-hmm.
So if you want help factoring, you can go to program and go down to the one that says factor, which is number 7 on mine. When you punch it up and it starts out, it's just like the quad. You put in the numbers of the one you want to factor. So like if I was doing that top, I'd put in a 1, negative 5, negative 14, and that'll factor that into the x plus 2, x minus 7. And then on that bottom, my a is 1. Since there's no x term in the middle, that would be 0, and then negative 4. And when I hit that in there, I get x plus 2, x minus 2. So that'll help you factoring if you need a little help.
So my calculator died the other day, and so it cleared out the whole thing.
Oh.
I'm just now realizing this.
Okay.
Because when I press program,
so
wow.
So let me ask you this. Are you busy on Tuesday, Thursdays?
No.
Well, I was going to say, because I got office hours I got to do on Tuesday and Thursday still.
Okay.
And I do them from, oh, let me think. I'm doing them from like 2:30 to 5.
Okay.
If you want to um, come up there during my office hours, either Tuesday and Thursday, and I can load it real quick for you.
Okay. Well then, yeah, I can do that tomorrow,
Okay,
Tuesday.
so just come up there tomorrow sometime between 2:30 and 5, and I'll load them programs up for you, and you'll be good to go.
All righty. That sounds good.
Yeah, that's the only thing. When what happens is if there's like a watch battery in those, and if that watch battery ever gets low, it won't save your programs when the batteries go dead.
Mm-hmm.
Oh, we got to finish this up. So there's the only thing we can do now is I got an X plus 2 that matches the X plus 2 on the bottom. So you're going to cancel them out. So your final answer will be the log of the X minus 7 on top over the X minus 2 on the bottom. So these ones didn't need parentheses because of the fraction. It knows that X minus 7's on top and X minus 2's on bottom. So that one you could get away without using those parentheses, okay?
Okay.
Alrighty, so that is our 9-5. So what we got coming up is 9-6 on Wednesday. That's going to be solving equations. So those can be a little tricky. And then you're going to have Thanksgiving break next week. When we come back from break, we'll do the 9.7 and get y'all ready for test 4. And then after that, girl, all we're doing is studying for that final. I think y'all's final is going to be due by December 14th or December 15th. I haven't
The
seen
15th is the last day of the semester.
again.
I said the 15th is the last day of the semester.
Yeah, so I think that's the last day that we can have y'all doing the finals. And they're going to be online again, just like all the tests. So I'll probably open it around 9th or 10th and give y'all till 15th to get them done.
Okay.
Okay. All righty. So that's it for this, and I will see you Wednesday. Okay.
Or tomorrow if I
Or
come
I'll
up
see you
at
tomorrow if you want them programs.
office
Okay.
hours.
All right. See you tomorrow then.
Mhm.
All right. Have a good one.
All right. Bye.
Bye. Oh, I did record that.